Hello everybody, and once again welcome to Pankaj's Echelon tutorials. In this today's session I am going to solve May-June 2023 paper, and the paper number is 41 of physics, that is 625, okay, 0625. And I'm going to solve question number 10, which is pertaining to the space physics topic, okay. So question number 10 says that Pluto is a dwarf planet, and that is shown in this figure 10.1, and it shows the direction of the motion of Pluto as it follows an elliptical orbit around the sun. So you can see that sun is at the focus of this ellipse, and the Pluto planet is following this particular path. Okay, so it's going in the anti-clockwise direction, you can say. Right, now this is the point X, this is the point Y. Right, now the question number A says that point X is the point in the orbit closest to the sun. So X is the point which is closest to the sun, and the point Y is the point which is further away from the sun. So the distance from the sun of point Y is more, and the distance of the point X is less from the sun. Okay. The orbital speed of the Pluto varies as it orbits the sun. Now you know that the orbital speed always varies when it is traveling around the orbit. Okay, so AI, the describe how the speed of the Pluto varies as it moves from X to Y and then back to Y and back to X. Okay, so starting from X to Y, now this is the point X, and at this point the distance between the sun and this point particular Pluto planet, has to be less. So when the distance is less, the gravitational potential energy will be more, isn't it? Gravitational potential energy will be more. And because the gravitational potential energy is more, the kinetic energy will be less. And hence, or you can say kinetic energy is less. Okay. Now this is happening when the now the question A is describe how the speed of the Pluto varies as it moves from X to Y. So this is the reason for that. So we will have to just mention what is happening to the speed. Okay, so this will be coming in the uh, uh, next question, right? So describe how the speed of the Pluto varies as it moves from X to Y. So when it is moving from X to Y, okay, this way, moving from X to Y, it is moving away from the sun. Okay. So when it is moving away from the sun, what will happen to the speed? The speed will be decreasing. Okay. So when a planet is moving away from the sun, the speed always decreases. So we can write that the speed decreases as it goes from X to Y, because X to Y, when it goes, it is going away from the sun, right? And the opposite happens, okay, when the sun is traveling from when the Pluto is traveling from Y to X. Okay, so speed will be increasing. Speed increases as it goes back to X from Y. So this should be the answer for AI. Okay. Now A double I. The question is explain in terms of energy transfers why the speed of the Pluto varies in this way. Now, first of all, you should know that by the law of conservation of energy, the total energy remains conserved, isn't it? So first we'll write that the total energy, the total of potential energy, the total of gravitational potential energy and kinetic energy remains constant. Okay, this is because of the law of conservation of energy. Now what happens is when this particular planet Pluto is when Pluto goes from X to Y. Okay, first we'll talk about x to y. When it goes from x to y, let us see what happens. Okay, so when it goes from x to y, okay, here the potential, gravitational potential energy is more, okay, because it is closer. And here the gravitational potential energy as it goes to y, okay, no, this way. As it goes to y, the gravitational potential energy decreases. So when it goes from x to y, the gravitational potential energy, what it happens? It decreases. So we can write when the planet goes from x to y, the gravitational potential energy, okay, it increases, right? Because the distance is increasing. So as the distance increases, the potential energy increases. So from at x, the distance was less, and at x, the distance is less, and y, the distance is more. So here the gravitational potential energy will be less, and here the gravitational potential energy will be more. So gravitational potential energy increases when it goes from x to y. And because the gravitational potential energy increases, we can say that hence the kinetic energy will be decreasing. Okay. Now just the opposite happens when it goes from y to x. So when Pluto goes from y to x, okay. Now what happens when it is going from y to x? The gravitational potential energy. Now this gravitational potential energy will gradually decrease, and hence the kinetic energy will increase. Okay. So this is the reason that we said that speed decreases as it goes from x to y, and the speed increases as it goes from x to y, uh, uh, going back from x to y. Okay. Now question number 10b. The temperature on the surface of the Pluto is 43 Kelvin. Convert this temperature to a degree Celsius. Okay, so we know that theta in degree Celsius is equal to uh, temperature in Kelvin minus a 273. Okay, the temperature in Kelvin is given as 43. So 43 minus 273 works out to minus 230 degrees centigrade. Okay, so here I'll write minus 230 degrees Celsius is already given, so no need of writing that. Now B double I. Pluto has a white surface as shown in the figure. Okay. Pluto has white surface as shown in this figure 10.2. And 1 second. Yeah. Pluto has a white surface as shown in figure 10.2. As the Pluto rotates, the white surface alternately faces towards the sun and away from the sun. Okay. So you can see that this white surface, many a times, suppose the sun is over here, right? So suppose this is the sun, right? So the white surface will be facing the sun, and when it rotates and the white surface goes on the other side, the white surface will be away from the sun. So at times it will be facing towards the sun, at times it will be facing away from the sun. So explain how this affect the temperature of Pluto as it rotates on its axis. So to answer this, you'll have to put some, because this carries 2 marks, so we'll have to put some good explanation. So the first thing that you can say is that the white surface is a good, no, it's a, I'll write WS for white surface. Okay, so white surface is a poor absorber and a poor emitter. Okay, so that's the first point we will write. White surface is a poor absorber and poor emitter. Okay, the temperature depends upon how much radiation, okay, from the sun is absorbed by a body. Okay, So white surface being a poor absorber and a poor emitter of infrared radiation. Okay, the temperature will depend upon this particular concept. Okay, because it is a poor absorber, what will happen now? Now what we can write is, uh, first we can write that white surface when it is facing the sun, white surface facing the sun will show, because it is a poor absorber, it will show less increase in temperature, right? Now black surface, BS, when the white surface is facing the sun, the black surface will be facing away from the sun. Okay, so black surface facing away from the sun will, when black surface is facing away from the sun, it will show more decrease in temperature. Okay, or if you want, we will write this way. This will make you understand well. Okay, yeah, let us not write this. Let me put it this way. White surface facing the sun will show less increase in temperature, and white surface when it is facing away from the sun, okay, when it is facing away from the sun, will show less decrease, okay, in temperature. It will show less decrease in temperature. Okay, and black surface on the contrary, when it is facing the sun, okay, black surface when it is facing the sun will show more increase in temperature because it is a good absorber, and whatever is a good absorber is also a good emitter. So black surface facing away from the sun will show more decrease in temperature. Now this can be understood in this way also. All this, for all this reason, I can write that uh, whatever is getting, if an object is getting hotter faster, it will get cooled also faster. Okay, so rate of increase is always equal to rate of decrease. Okay, so that is the logic that you can use here. And overall, if you see, then the variation in the temperature of white surface, temperature of the white surface is less. Okay, so there is, for white surface there is less increase in temperature, and for the white surface there is less decrease in temperature. Overall, the variation in the temperature of the white surface is always less, okay, throughout the rotation. Okay, so these are the answers for this question number 10, and I suppose I'll end my session today here only, and in the next session I may cover some other uh, year paper, okay, for the same topic, that is space physics. Is that clear? So if you happen to like my video, please subscribe to my channel, and that's all. Bye. Take care, all of you.